In number 34, 36, and 38, we are to find the zeros of the functions algebraically. And they are grade bubble problems, so you should be doing all of this by hand. And the only way you're going to get better is just to deal with it and do it. So here we go. In number 34, if we want to find the zeros algebraically, that means we must factor this quadratic polynomial, or trinomial in particular. And when we look more closely and realize we have a coefficient on x squared, using the technique I've taught you, we're going to turn that equals into an arrow, which says the previous step implies the step I'm about to write. It does not equal the step I'm about to write. So you put a 3x in the first spot of each, and then you look at the sign of your constant, and since it's minus, we're going to put a plus and a minus. And then to get our factor pairs, we multiply the leading coefficient times the constant and get 12. And that tells you what you're looking for the factor pairs of. And then the fact that we have a plus and a minus means I'm looking for a pair of factors with a difference of the middle coefficient. So we start with 1 and 12, which have a difference of 11. That's not our pair. So then we go to 2 and 6, which has a difference of 4, so we stop because that's what we're looking for. We put the big number to match the sign of the middle term, and then we resolve the issue we created by bringing in the extra 3 by factoring it out wherever we can. And we can factor it out of this first binomial, and we get 3x plus 2, 3 times x plus 2. And you can't factor anything out of the second binomial, which is good, because then this gives us the result we need. So we just throw out the extra 3, and then we write our answer, because we take the zeros from the factors. And our first 0 is negative 2, because negative 2 makes x plus 2 0. And then our second 0 is 2/3, because that's what makes our second factor 0. And if you can't look at them and tell what your zeros are, you set each one separately equal to 0 and solve for x. Then we look at number 36, which initially probably makes you a little scared because it's cubic. But if you remember that your first step to factoring is always to take out what they have in common, this problem becomes really, really easy. If I take an x out of x cubed, I have x squared. And when I take an x out of minus 25x, I have minus 25. And then when I write that, I realize that I've just written a difference of 2 squares, which means that can be factored into x minus 5 and x plus 5. And then I can get my 3 zeros from my 3 factors. And 0 would make 0, 0. And positive 5 would make x minus 5, 0. Negative 5 would make x plus 5, 0. So I can write them together as plus or minus 5 after the 0. And I have listed all 3 zeros. And I'm off to number 38 to close out this video. Again, we have another cubic. Again, you might worry that you're going to have to factor a cubic, but you're not at this point. You're just going to look for what they have in common, which would be 5x. If I take 5x out of 5x cubed, I get x squared. If I take 5x out of minus 5x squared, I get minus x. And if I take 5x out of minus 10x, I get minus 2. So I now have a simple little quadratic to factor, no coefficient to make it more complicated. So I set up my binomials, and actually make it look like they're multiplying there, and put an x in the first spot of each. I have a minus 2, which means I've got to have a minus and a plus, and there's only one factor pair for 2, and that's 1 and 2. And I put the big number to match the sign of the middle term, so I'm going to put the 2 here and the 1 here, and then get my zeros from my factors. So 0 would make 5x 0, so that's my first 0. 2 makes my second 0, my second factor 0. And then negative 1 makes my third factor 0. So the 3 zeros, in no particular order, are 0, 2, and negative 1. And that is the end of this video.